geospatial data from monitoring entire cities in real time. This data is the backbone of innovation that keeps us connected, informed, and prepared. Isn't it fascinating how this invincible system impacts nearly every aspect of our daily life? To take us deeper into this fascinating world of geospatial big data analysis, we have with us an exceptional expert today. It is my distinct pleasure to introduce Dr. R. Bhushan, an eminent former scientist from one of the under the Department of Space in Hyderabad, Telangana. Dr. Bhushan holds an MBA in Operational Research from IGNOU and PhD in Big Spatial Data Analysis from NIT Warangal. With over 28 years of service at the Department of Space, Dr. Bhushan has made significant contributions to the data and network security, including the development of indigenous unidirectional data flow devices and network aggregators. His expertise spans integrated hardware for satellite data acquisition, processing, and sophisticated GIS-based decision support systems. Speaking about his current work, he is visiting faculty member at institutions like IIIT DM Karnal and National Institute of Technology, Warangal, with research interests in distributed computing, cloud computing, AI, and quantum cryptography, with over 30 publications in esteemed journals. Ladies and gentlemen, please put your hands together and join me in Funny Bhushan onto the dais with a big round of applause. Welcome, sir.
To be here at the podium?
Pardon?
I'll have to be here at the podium, or you have a microphone?
Anything is fine, sir. You can use the handheld.
Good afternoon, everybody. Good afternoon, everybody. Hope I'm audible? Yes, sir. Thank you. And I'm sorry for the delay. I had to travel all the way from SU to this place. So you know the traffic these days. So that's the problem. That's the big data that we have, the big volumes of traffic that we have. Anyway, without much ado, what I tried today, try to cover some topics on what, like initially going into spatial data, right? We need to understand, and most of you understand spatial data anyway, but then we'll just have a refresher kind of a thing to understand spatial data. Go into big spatial data, we will look at the data frameworks that are used for big spatial data analysis, and we will also talk about, I'm here basically probably because I have worked with ISRO. So we will talk about why remote sensing data qualifies as big data. Okay. And then we will look at some of these, I don't know how many of you have seen hoardings at Makkah of learning, SR Nagar, that Amir Pet area, which is supposed to be that place where every new technology comes up onto the hoarding. Anyway, Hadoop is a synonym for big data. It is not big data as an entity. We all need this, right? In India, I think the Xerox company owner will be very happy because we call every photostat as Xerox company. So he will be happy that every nook and corner is covered by his apparatus. And then even the auto driver will tell you, Google it. Nobody says search it. Everybody says Google it. So we are good at that. So big data and Hadoop are synonyms as of now. So that's what we will be looking at. More than big data these days, like I was surprised. I finished my PhD in 2019 and I did some work on big data, big spatial data. But I was surprised that by 2020, 2019, after that, like nobody was talking about big data. Everybody was talking about artificial intelligence. ML and AI is the key catchword or a catchphrase these days. But all that has been possible because of big data. I think we will try to see why that is so, right? I have always been fascinated by looking at if when we travel by the aircraft, you look down from never being able to identify which is the direction I am coming in to land at the airport. Right? That's been a real, something which has eluded me for a long time. I've been working with the Geographical Information Systems group when I was in my earlier career. Okay, but nothing really, helps you in doing that, right? So I'd like to know if anybody could identify what is there in this image. What is that red circles that are there in the image? Satellite imagery. Any guesses? No problem. Because I will also not be able to tell, because I got it from the internet and the tagline was there, so I knew what it is. But otherwise, I will also not be able to make out. Anybody can make out? Mountain. Okay. Wind. Cyclone. And nothing is ruled. Nothing can be ruled out until unless you are the best image analyst that is available. It is just smoke. It is just smoke, nothing else. The problem, I've been asked. I also teach. I also talk to people in administrative staff college of India. Somebody asked me, sir, the path when the rocket takes off, okay, the path we see is it takes a circular path. It goes down after going up. Why is it so? So Earth is like a lot of mysteries in it. It holds a lot of mysteries in it, and it really you cannot really make out in doing that. Right? We had colleagues at our department who were interpretation experts. Okay, they were supposed to look at cross-border images and tell where there is a tank or where there is a canopy hiding the tank. Okay, where the vegetation, where is the vegetation, where is the nuclear facility. Okay, these were people who were really experts at satellite images. Okay, so the amount of time that you spend on an image will actually give you the details. I don't know how many of you have seen the old Doordarshan. There were dots, amoeba-like structure. Like, there was a time, I think it used to start at 7 o'clock and end by 10 o'clock news or something. Okay, before that, there is nothing but small amoeba floating on the screen. Okay, if you see something called synthetic aperture radar images, somebody has shown you that synthetic aperture radar images. Okay, they are supposed to be active sensors. You have seen those images. That image looks exactly the same as what I am talking now. You will not be able to make out anything from the image. It's processed properly by people who know how to process this image. Okay, so similar situation. Any guesses? Okay, that's great. It's an oil slick of the Gulf. Again, the problem is that there are certain ways of showing an image. Okay, we call them false color composites or natural color composites. Okay, false color composites also give you a different feel that is based on the table that is used to map the colors. Okay, this is a water body definitely, but it's a dry lake. What I am trying to say here is that the nuances of satellite imagery are so many that even a human eye, which is supposed to be naturally intelligent, leave artificial intelligence aside, which is supposed to be naturally intelligent, also can be fooled by many things. You may not really get the entire picture, okay, till expert in looking at an image. So why all this? Because we are going to talk about spatial imagery and spatial imagery processing that we are talking about, right? I don't think this is really like, the kind of resolution it is and the image that it is. I don't think anybody can make out anything from this. But this is supposed to be the London, an image of London, Westminster Abbey here, somewhere near that. Spatial data. We have all come across spatial data. Okay, if you ask this question, where is the nearest petrol pump? Okay, you've looked at spatial data, you know about spatial data, right? So you've used spatial data, right? So this is something which has become so colloquial these days that every one of us uses Google Maps, even knowing that there is so much of intricate data that goes into build that map, right? So that's what we are at today. Look at this experiment that is being done across great cities in China. People are using spatial data. You will be stuck for 47 minutes or 47 seconds. Order to your car now. Hoardings. There are hoardings. This is a hoarding that I am reading here. There are hoardings on street crosses which talk about that, and at Andrea and the Red Honda, your walker arrives in 7 seconds. The order arrives in much time. Okay, this is the usage of spatial data that is happening around the globe. Okay, I'll come to one more example. Sometimes we'll see what it is. Okay. How big is big? How big is big? We moved from bytes is long ago, right? We moved from terabytes to petabytes maybe 2 years back, from petabytes to exabytes to zettabytes. We have lost track of words, now we are going back. A yottabyte is more than a zettabyte. We have already collected 175 zettabytes of data. How are we collecting all this? The problem is that we are all carrying sensors which are collecting information about each one of us that we don't know is getting collected. second reason, more important reason, is that we didn't have the compute power to use that population of data, large amount of data. This became possible. This became possible when we got GPUs activated in 2007-8 time frame, and also the let me see this. I have the picture there. Yeah. These were some countries which had their own indigenous satellites. Some countries which had their own indigenous satellites, maybe up to 2015, 16 time. Okay. Then these are the countries today, maybe after 2020. These are countries that have their own want to today work on clouds, right? There is a lot of data, and a lot of data can be processed only if we have lot of systems. A single monolithic system, okay, does not help in the way a distributed file system can process, and hence the distributed file ensure that you make the cluster. And once you have done it on one system, copy that same entire folder into different systems and you are already ready with the cluster. You need to add a system to the cluster, put it along with the cluster, copy this and mention it as one of the data nodes in the name node. That's it, you are ready with the entire cluster. What does this can be one more that it defeats the purpose of execution of distributed processing, right? There will be different nodes and you will do a shuffle of that, then you choose the reduce it. And reducing this is the terminology of execution. Reduce is that it brings in the pairs and comes into two significant the other housing. The final is brought out by the reducer. So what is the same function without special. Say we are talking about special data. Right? So means we chunk data in squares or rectangles. We store them in values. Okay, and it says what we are doing here, edge detection function. What is each of these chunks, the T is the important edge detector. It will be a zone in the end of the sample is reached. Okay, so use that operator data, and hence you are able to create get the edges in that spawn sample. So what is what you do? Check. So that's what we try to do. Not the land is going to be. Okay. Yeah, again. Like, for Hadoop, the following contains lines. Okay. And what important are save, etc, live, clean, and share folders. Okay, the rest are all like logs and all connected, so that's not really important. You look at etc folder. In etc folder, it's got different files which are important. The HTML file, four-side file, maplet, and the yarn set. These are the four files which are configuration parameters. Okay, how to configure a particular Hadoop cluster? And there is one more file, master and slave. Oh, sorry, WordPress. So this file called WordPress is the file in which you need to give the identity of your system as a part of the cluster. That is all you need to do. Then you have the master file, which actually every version has got a different name, so that's why it is there. Okay, you have got a master corresponds to the name node. Right? I'll show you one of these files to just appreciate how much of a change you need to do. Okay? So this is what you need to do in a course-site.xml file, where you need to specify what is the from here. To specify where on which machine the master is running. That is all you need to do in a course-site.xml file. The default FS or the default file system is what it is running on the local host. Yeah, that's it. Thanks. Okay, so similarly, where one important thing here is the replication value. This by default is 3. We can, if you are using only a single system just to experiment, you can make it 1. Okay, and then you can also store the logs and the entire directory where you know what is the data node. Okay, each data node, it's also a data node. This particular system is also a data node. So we give the data node directory also and the name node directory also on this. Okay. If you fill it in these 4 files, okay, it's a matter of writing about 4 lines of code there in those files, and your Hadoop will be up and running. So your Hadoop will be up and running with this. It's starting name node, data nodes, starting a secondary name node of that, resource manager, and the node managers. Okay, all these 5 components are required for the Hadoop system to run. Once that is started, okay, you can see what are all the data nodes that are participating in this particular application. Okay, all that is visible here. Okay, so you get an overview. How much of memory, what is the capacity, how much of BFS is used, non-BFS is used, what are the live nodes. There is only one node, so it is showing one there. Otherwise, it will show you all the nodes that are active and that are part of this particular whole process. Okay, then you can also look at what are the particular file system, right? And you must be knowing about Linux, right? So Linux commands are directly usable on this particular thing. Only thing you have to precede it with HDFS, DFS. That's all. Once you precede it with that command, I'll show you one command here. So it shows me ls is the command that we use generally, right? So ls command is used and it shows me all the folders there in that particular Hadoop system, right? So this is how you can use a Hadoop cluster and you can keep track of all the processes that are running on the Hadoop cluster. So this particular thing, this applications is the one which you click on. You click on applications. It will show you all the applications that are running. It will give you a list of all the applications that are running. Click on each one of the applications. The application which is running, it will show you which data node is being used for processing. It goes to the detail of how much of the memory is being used from that particular data node to process this. Okay, if it has failed in between, which node has taken over from there, all this information you can get it from here, right? The scheduler will tell you how it has been scheduled, what is the used capacity of that particular node on which it is running, all this information. UI. You don't need to write another UI for Hadoop, right? Once you install the Hadoop and start running the processes, yes, it will be ready and usable. So what are the processes once again? The processes that are running are the node manager, resource manager, name node, secondary name node, and the data node. Okay, so if you are using only as a name node, three processes, the other two processes will be running on the data nodes and the secondary name node system. Right? So this is how we can use a Hadoop cluster for processing not only normal data, we can also process spatial data with this, and there is a lot of research that is being done and lot of people are working with spatial data on Hadoop. I think the next big thing that will come will be which will run on Hadoop, because basically we are looking at data, okay, large amounts of data, populations of data in AI, right? Because to learn, I'll just quote an example here. I was a consultant for one firm which was working for an insurance company. The insurance company wanted to know from a photograph, okay, whether there is a dent in a car or. They had to collect almost about maybe 10 to 15,000 photographs of the dent and the car together in order to train it to identify a dent. But again, the problem is a dent in a maybe a CentOS is a design in a Swift Desire. Okay, so again you need to collect data. So there is so much of data that you need to train a system, and if we can do it in a distributed way, using even the GPUs, if we are able to do it in a distributed way, probably that will give us a better, efficient result, right? So I believe that's something that will be coming up in the future, right? So this is what a marriage between big data and AI can help in order to give better, efficient results. Okay, I think running out of time, 3:50, Mr. Correct? Fine. So I'll run a code and show you what it is. Okay, so here we have some examples. Yeah, we have some example code here. We'll try to run some word count example here and check. And I'll show you on the Hadoop cluster how the division of labor is happening, how the nodes are being allocated. File input. So in this I have text files from which I'll try to do some word count example. Okay. So now you're seeing here the application which is running the cluster. And you click on the application, and it is showing you the map progress, right? The reducing progress, and how many members, how many reducers are running on this. Use the job ID in order to go to the. So these are the tasks, the map tasks which are running, two map tasks which are running on that particular system, right? This also will show you what its status, whether it is completed, whether it is running. Okay, all this information is shown to you in on which node it is running. All that is shown to you. I think the process is completed. Yeah, that's why it's not able to. So here is where it shows you what was the launch time, what was the start time, what is the end time when it finished, and whether it's a succeeded finish or like what it has done, whether it is failed. So you can also have logs through which you can check what all has happened, how many of them have been processed. Right? Oh, I don't have that history running on the system. The history is not there, so you are able to see when an application runs, what is the ideal application, and show you how many numbers are users are running for that application, and each mapper you can go down to the job start, okay, and you can find out each task, which node it is running on, okay, how much time it is taking, whether there has been a failure to a different node. Okay, all this information comes out in this particular UI itself. The GUI here gives you that information. So I have created a payout folder. So it is showing me the count these words. Okay, this word count. This is the word count it is showing. Right? Each word has been counted from the entire two text files that are given in exhibit 1. I can download it or I can keep it in the HDFS. The HDFS will again store it the same way it has stored the input data. This to break it into 128 MB blocks and store it in the output folder. Okay? So this is how HDFS component works. Okay, if you have any questions, I can answer that. From my side, I think I have completed whatever I thought of planning of. Okay.
Participants for being enthusiasm which makes this session so special. And remember, this is just third day of FDP. We still have 3 more exciting days filled with knowledge and discovery. Let's take this journey forward and continue to use patient technology. Once again, let's give a huge round of applause to Dr. Bhushan and your for being such a great May I now request Head of Department and Coordinator of FDP, Dr. Anusha Ma'am, to felicitate our guest speaker, Dr. R.